So today what we're going to talk about for this event is substation design with Inventor model states. This is more focused on P4I, but the P4A product will take model states in the INEX. So you could have model states to import into the P4A tool. But the P4I tool, this is what I'm a little bit focused on today. You can see I have an example here showing this bay assembly. This is what I'm calling a bay assembly, subassembly. And this bay assembly was actually modeled in this manner. So it made a elevation view real nice. But you can see I have model states for this island subassembly of the circuit breaker island subassembly. And this is the same assembly with different tags, different setup. Same as this is a switch island. It's kind of hard to see in this image, but we'll look at it a little bit later on. So I'm going to go down a page. By the way, it's Steve Kaufman talking. If anyone doesn't know me, give me an email if you don't know me, and I'll answer it. So we're going to go down to a page. Our topics are going to be the model state types. I figured there's two types of model states, and we're going to talk about that. I'm going to show model states combined. This is a model states combined, and we're combining model states with positional representations. So it's really cool to do it this way. It makes the model a little bit lighter, and we'll talk about that. We're going to talk about substations, not substitutions. Substations with model states. I have some notes on this, and I leave this up here because people forget that we have some new tools. It's really cool in Inventor since 2022. They've been adding new tools to Inventor in the patches update. It's not just a patch fix update of bugs. It's actually adding new tools now. So it's pretty nice to have. So when I'm talking about model states, I don't know how much time I'm going to use up, but I have till 4 o'clock, I believe. So I might use it all up, but let's try and get time for Q&A. So I look at model states as having two types. I see it as having suppression model states where we suppress bodies or models to get what we want. And I also talk about it as instance model states. So I'm using model states as, I see it as two different ways. And the instance model states allow us to have parameters and I properties dedicated to that model state. So what I'm doing here in this image here, you can see that I have an instance model states and a suppression model state. The suppression model state is turning on and off the tag plate. And the instant model state is changing the tag value as well as the parameter of height. And you can see it on both of these. So I have the same assembly, the same parts, right, behaving differently because of model states. I'm using suppression. I'm turning things on and off in this, and I'm also using parameters in the tag. All right, so I'm changing multiple things in here. So this is the neat thing about model states is that we have this instance. We never had the instance tool before that we can have tags and height parameters. We can change positions of things. There's a lot of things we can do, but there's not everything we want to do, right? So let's go down here. So here is a bolt assembly. This is a bolt assembly combined. So I have positional representations in this bolt assembly, as well as model states for the bolt itself. So this one bolt assembly, I'm doing only 1/2 inch on this. I wouldn't go for 1/2 inch and 3/8 and 3/4. I would just keep it to one diameter and maybe just specialized just for a NEMA arrangement or for a BCD type of area. So I wouldn't have one assembly doing thousands of things because you don't want to do that. You don't want too many model states. But in this case, I have a model state here that's doing positional and parameter. So I'm doing positional, parameter, I properties changing. So the bolt assembly itself, this is the table from the model states. So you're selecting it by the gap or grip. A lot of people use grip. I have a habit of calling it gap. But if I have a gap of, see, this is 1.125, that's 1.25 inches. All right, so this is the idea behind, this is a method we did years ago. But you can see I have different grips or gaps all the way down. And when we get into a smaller size, the bolt length changes so that my description and my part number changes, right, with this for that bolt. So I'm using the same washers all the time, but the bolt length changes. When the bolt length changes, I have a parameter change for the length, and I have I property changing for description and in part number. And it doesn't need to just be those I properties. You can change all the I properties if you're crazy, but you can do this type of thing. So this is what I'm doing here. And here's the bolt itself. So this is just the bolt. So this is the table here in the model state. So for those who don't know model states, let's go into this. And I'm going to open up that bolt assembly. And I have it called this one here. All right. So you can see I have bolting up here. I have my model states all named up top here. When I come down here, I have representations, positional representations, and these representations call up the representations inside of, well, the spacing. I'm sorry, I got ahead of myself. This is changing the positional representation of the washers. All right, so if you look up here, we have the grip or the gap. So I even got gap and grip here. Just, I think I did this for Kelby, because he always corrected me. But you can see I got 2 inches here for this, right? So that's what the positional reps are doing. This is all just changing for bolting in that. And when it comes down to the bolt itself, where is the bolt? This spring hex nut. Why am I, oh, well, this is the bolt right here. The bolt has model states, and this is what's changing in the bolt for the length. So if I open up this up, you can see my model states. I'm going to go come up to model states, right click, edit via spreadsheet. So you can see the spreadsheet, I'm changing title. See, you can see I got to correct this. This should be corrected. I'm not going to correct it today. We got width across flats. That's pretty standard. So I could get rid of some of this stuff in here. But the key thing is part number and description is changing and parameter length is changing. All right. So that's what's changing on this bolt. So as it goes into in the parts list, it's going to have the parts list is going to update to show the correct part number, description, and everything we need for it. So if I change this to a, let's say a small one, that bolt length has changed now. That bolt length is now, I don't know, it's not 2 inches. I don't know if it updates for us down there or not. Let's go up to the long one. You can see how that bolt length is changing length. So here it's 350. So that's 3.5 inches long. And if I come down to a small gap, I have it set to only 2 inches long. Right. So, and you can change that. You can set it up the whatever way you want. You can use grip instead of gap, but you can see what I'm changing in here. So I'm using positional representations and I properties and model states with I properties and parameters. So you can, that's what's all changing inside this bolt. Let's go back to the PDF. So that's where this is coming from. And I should mention that it doesn't matter. I'll talk about that later. So when we're looking at a substation now, what this allows us to do is to have these islands different. If I look at the old method of doing it before model states, when we look at this, well, I don't know why that was. We have changed my selection set. This island here, I'll find it in the browser. This island is this guy here. So the file name in the old version, pre-model states, the level of detail world, I had to have a new name for that island just because my I property changed on the tag. So each of these islands is a different assembly because my I property changed in the tag of the part. Then each circuit breaker part has its own file name as well, because of that tagging. So what I'm ending up having is more open documents in session down here in the bottom right, right? I'm having more documents in session. That's not just with this, with all of my islands. Anywhere where I have a tag, right? I have to have a whole new part. And if you pay attention to how Inventor works, open documents in session makes the model heavier. The number of occurrences, I can have 70,000 occurrences and not have a real issue with my model, but it's the open documents in session. If I get over 3,000, it starts slowing down. I'm not saying that's a limit by any means, but it starts slowing down. I've seen people with 7,000, but it's pretty slow. So I'm trying to lower that number. So in this old case, I have each of these as a different part number, different file name, different component, only because I have to change the tag. In this world here, in the model state world, I have a different setup. So I can come up here and go find in browser. I have the same assembly 3 times in here, but they're different model states because I'm changing the tag. So I'm going to open this up. So here's my island subassembly. I got some detail on here. I run my grounds to the lowest connection. Some people are different, but it's not imperative. I have my above grade conduit. I have a tag plate, and this is OG122C, right? So if I want that as a different tag, I can come up here and just change my model state. So now it's 01155. If I look at the I properties of my 151C, all right, you see how that tag is changing? So it's the same part that tag is changing in the circuit breaker. I'm not looking at I wasn't looking at the assembly. I was looking at the circuit breaker, right? So I have that tag that changes. Not only that, the nameplate is changing. So if I come up to 122C, you can see that changed as well. So I'm using the same part for same assembly, didn't have different tags, different parts on it. I can move things around here. What you don't want to do is move too much. You're better off if you're moving the cabinet around to all 4 sides. You may want to have a separate assembly for that. You may want to test it to see that it's completely stable and moving it around. I would just double check that, but it should work. Autodesk says it works, but so you can go go with that. So you can see what is happening here. There's in the same thing I'm doing with the switches here, right? These switches have a tag number. If I come back up to here, right? Those switches have a tag number, and I'm able to do it that way too. So what I'm doing is reducing the number of occurrences by doing that. So if we go back to the document, this is my comparison, right? So the total size of the model with model states was 790 megabytes. When I zipped it up, I got 790 megabytes. The older one was 530. So all right, so model states is making the model larger, all right, by 260 megabytes. So you think but that's the entire model, right? The number of files have reduced. All right, so I'm going from 1,400 down to 1,500. So I got less models in my assembly, or number of files, I should say, not open documents. Occurrences, I got 11,000 occurrences. My occurrences are going up because it makes sense because I'm reusing the same file name, right? Open documents and sessions has gone down by at least 34. All right, so it's not really apples to apples because I added 200 disc spring washers. So this number here, this occurrences in the model would be even higher. All right, would be up another maybe 200. I don't know. But what you're getting is a larger file size, but less documents in session. And less documents session is a goal that I like. So what is happening behind the scenes? Yeah. Okay, so let's see what's happening behind the scenes. So here's the model state notes. All right, and this is part of you have this document in the chat. So each model state member is represented in storage within the model file, as a separate stream, which is like saving a file inside of a file. It's like a zip file. As a number of model states increases, file size will increase. And this is Kevin was asking me about this, Kevin from Patton, but others were asking this as well. From Autodesk, file sizes increase is expected, and you can see that in Autodesk documents. When placed in assembly, only the active model state is used. So it's not seen in the assembly. It's not seeing that whole zipped up part. And we're going to look at that in a minute. It's not going to see that whole thing. It's going to only see that active model state, and the data, which data is very light. It's just text. It doesn't really see that in the model. So that bolt with extrusions, remember we're looking at this bolt, we're making it longer by changing the parameter, changing the eye properties. That bolt ends up 1.7 kilobytes, 1.7 megabytes. So it's bigger. Definitely it's bigger. I have 12 model states in there, which I think it's a little bit on the high side. I wouldn't want to go up too much higher. Just because I've had experience with customers, they do these great big model states. I got one guy that did about 30 model states for, you see this bus design here. He did like 30 model states for this huge bus design like that. And it started to, Inventor would just turn off, no error, no nothing. So you don't want to be really big, but I find it very stable at like under 15, 5 or 6, definitely no problem. 12, I'm okay with. I've never had a problem with this one, so I'm happy with it. But you can see what is happening here. So bolt with eye property model states only. So I took out the model states for the extrusion, and the part was only 573. So this is just changing the text in the eye property, which we know would be light. Text is so light. And if I had the bolt with no model states, it was 142. All right. So this is a nice bolt. It's fairly simplified. So let's go back into my Inventor. Let's go look at that bolt. So I am going to go into that bolt. Here, see here, no model states, bolt with model states. All right, so I'm going to come in. If you ever see 7-zip, it's free. It's like instead of the other zip file, you can use 7-zip. The only problem with 7-zip, wherever you zip it to, they need to have 7-zip to unzip it. So I rarely use it, but I can open the archive of this. I'm going to open up this archive. And I got member docs in here. So remember, I had 12 model states. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So you see all those model states are in here. The size, this is in bytes, right? Don't think this is kilobytes. This is in bytes. So it's 123 kilobytes. And you can see the size of that file is changing. But when it's the model state, it's only using this one. All right, it's only using this one when it loads it up in the instance. Okay, so you can see what's happening. I think I said this like 3 times. You can see what's happening here. You have it all zipped up in this data in these member docs. So when you're combining the model state parameter with the positional reps are lighter. So that's a nice thing to do, is combine it to keep your model state even lower. So you use less model state because you use positional reps to be able to do that other work. So that's what's doing in that bolt assembly. Positional reps for the washers, because they don't change. They're kind of static, just positional. But the bolting length changes. So you can, okay, so let's go into this guy. Here's my general arrangements, which I have model states in here. And we can come into 7-zip member docs. And I got 1, 2, 3, 4, 5 model states in my general arrangement. And those are mostly of just suppression model states in my general arrangement. I don't really need to go the other ones. So I want to show that other positional rep one. I have another one. There she goes. Okay, I want to open up this. I want to make sure we understand what I'm saying with positional rep one. So this is above grade. Here's this guy here. Let's open this guy up. So if you ever read some of my documents, I talk about combining assemblies so that you can do different things. So I'm going to look at this, this piece of pipe, and I'm going to put my above grade tools. I'm going to browse to fitting. Okay, come down my fittings. Okay, Josh, cross your fingers. We're going to put this guy in. I'm going to put it on that pipe. So you can see I have my assembly here. This is a phantom assembly. I got bolting. I have my tap, and I have my fitting here. All right. It's not touching there. All right. You can see it's not touching there. So let's find that in the browser. Come up here. And here's my bus tap assembly. I'm going to expand it. So this is for a 5-inch. So now it's attached to 5-inch. If you don't know this type of tap, the same tap is good for a multiple range of diameters of pipe. So there I am changing that. Now I'm going down to my representations. Here's my positional rep, and maybe I want to change it. What angle is it on? So I'm using a positional rep to move it around. And the positional rep is lighter than the model state. All right. So I'm using the model state to position it. There's a work plane inside that tab to position where the bus work point is. And that's how it mates. And then there's the model state changes that that parameter in the work plane for the bus point. So that's what's going on. Oh boy, up here. Okay. So I wanted to make sure we know that. So what I also do, if you look at this guy here, let's look at this fitting here. So I make sure we're back into part priority. Find in browser. So for this guy, I put a bolt assembly on there, and I have this grip available to me to change my grip whenever I place this on. So this is placed on using normal Inventor or SDS tools here. I'm just browse fitting to place it because I can browse fitting for an assembly. And I'm placing it onto my NEMA pad. And once I place it on my NEMA pad, I can come in here and look at it and say, okay, what size of bolting do I want for this? Do I want 2 inches? Do I want 1.25? You can see it disappearing there. Do I want 160? Do I want 175? All right. So you're able to move it around like that. I don't know why I don't have the size. This must be it. All right. You can see that we're moving that around. And so I'm making that as a sub-assembly. So now I'm able to place these fittings with the bolting on, adjust the bolting right away, and I'm done. I'm hunky-dory type of thing. So we're seeing a number of things happening. The idea behind it is the instant of the model state is what's saved in the assembly, even though the part is a larger part, only the instance is used in the assembly. That's the way it's explained to me. So when you're using model states, refrain from creating large assemblies with model states suppressing or moving a lot of components. One guy, he had like 30 model states, and Inventor would just shut down at times. And once we reduced the number of model states in that assembly, it was a sub-assembly of a sub-assembly as well. So, you know, with many suppressions in a large assembly, there are examples of Inventor closing unexpectedly. I really like using the model states with positional reps because positional reps are lightweight, and the model state's a little bit heavy, but only in the file size. I would try and reduce the member docs because of positional reps. And that's what I was showing you with that tag fitting and as well as the bolting thing. I was talking to our vault specialist, Anthony Dahl from RAND about model states and how vault sees them. And it was explained to me, and if I'm wrong, forgive me, I'm not the vault expert, but what vault may not see the component in a search if you're looking for that model state I property, because vault only sees the primary model state properties, I properties, all right? So if you want to see what that model state I property was changed to, I believe it's item master that needs to be active. You have to have it with item master. I'm not sure of what that all curtails, but for something like this bolting, it doesn't really matter. I think it would matter more for something like a circuit breaker that you might be searching for it based on the tag, if you want to see the tag of that circuit breaker. You can always do your bills of material to separate on file name so that you can see the different circuit breakers with different tags if that's what you want to do. There's different ways of working around this. It depends on how flexible you guys are with your companies. I know substation utilities are not very flexible, but they get flexible at times. This is just something I put in here. You can change, you can look at my model here. You can see I got the dot here. It just tells me it's fully constrained. And this is one of those things that came up with the release.